All right, this problem is a sequence problem. It's, you got to find something, then find something, then find something, then you get to the answer. All right, so the problem begins at the top of this hill. This girl with a mass of 50 kilograms, I'm calling her M1. She runs with a velocity of 4 meters per second onto this sled. So here's a sled right here. The initial velocity of the sled, I'm calling the sled object 2. V2 initial is 0. The sled is at rest. So she jumps onto the sled. What's the first thing we have to find? The velocity after the girl jumps on the sled, right? So this is a collision, right? She jumps onto the sled, two objects become one. It's a collision. So we go, all right, so focusing right here, a girl jumping onto sled, M1 V1 initial plus M2 V2 initial. The objects stick together, so combine the masses, M1 plus M2, V final. What was the initial velocity of the sled? 0. So now we can find V final after she jumps on it. M1 V1 initial, M1 plus M2. So the mass of the girl is 50. Her velocity is 4. And then combined mass, the mass of the sled is 5. So combined mass is 55. Kilograms cancel. And we get final velocity after she jumps on the sled to be 3.6364. Don't round this because we're going to use it. You don't want to get rounding error. All right, so now let's kind of like modify the picture, kind of clean it up. So she's jumped on the sled. All right, so here she is now. She's on the sled. Together they move off with a velocity of 3.6364 meter per second. And then boom, down the hill they go. In fact, let's grab this. Let's see if I can do this. Go like this, go boom, kind of grab her like that. And here she goes for a ride. Ready? Woo! Let's see if I can. Come on, computer. I got a rotator. All right, here she goes. Ready? Whoa, down the hill. Bam! Now, she's going to hit her brother. Her brother's right here. What's the initial velocity of her brother? 0. But what do we got to do first? Before we analyze the collision, this is a sequence problem. You got to find something, then find something, then find something. A lot of things to find here. So what do we have to find before she hits her brother? We got to figure something out. What is it? Her velocity, right? Because look, she's going down a hill. She started up here, and the problem tells us that after she drops 5 meters vertically, that's when she hits her brother, right? So she's picking up speed. As she's going down the hill, she's going faster, faster, faster. So what type of energy did she start with at the top of the hill? Kinetic. So at the top of the hill, well, she has kinetic plus potential of gravity. Now I'm going to put the 0 point right here for this calculation. This is going to be the 0 point for this calculation. So up here, she starts with kinetic because why? She's moving. She starts with potential of gravity because she's above the 0 point. Now, at the moment she hits her brother, what type of energy does she have? All kinetic, because that's where the 0 point is. I'm sticking the 0 point right where the brother is. Okay, so now you plug in 1/2 mv initial squared plus mgh equals 1/2 mv final squared. All the m's cancel, makes it nicer. And then I would multiply this by 2 to get rid of the 1/2. So when you solve, we're trying to get v final. So v final right before she hits her brother is going to be v initial squared plus 2gh. That's what you get. So v initial at the top of the hill, 3.6364 meter per second plus 2 times 9.8 times 5. That's her h. So we find out her velocity right before hitting her brother is 10.5462. So that's the velocity at the instant she hits her brother. She's traveling at 10.5462 meter per second. Okay? So now what do? Well, okay, so now she's going to hit her brother. So that's a collision. So we go, okay, let's analyze this collision when she hits her brother. We go M1 V1 initial plus M2. You know what? I'm calling him M3. Let's just be clear. M3 V3 initial. 3 is the brother. That's going to equal, now they combine and stick together, right? M1 plus M3 V final. What's the velocity of the brother before she hits him? 0. So now we can find V final after she hits him. So V final is going to be M1 V1 initial over M1 plus M3. So this is going to be, let me turn this off. So M1 55, that's her plus the sled. Her velocity before she hits him, 10.5462. Total mass is 85. So now we have velocity after she picks up the brother as 6.824. Okay, and then now we can finish the problem. So the question we're trying to figure out is how fast is the sled moving at the bottom of the hill? Okay. So we're right here. So now, let me just revert this. Clean this up. So now she's picked up the brother. Erase this. So we got sled with the boy and the girl both on it. They're traveling with a velocity of 6.824. Okay, then what happens? They cruise down the hill, vertical drop of 10 meter, and the thing we're trying to figure out is when they reach the bottom, so there they are on the sled, what's their velocity at the bottom? So how do we do this? You could do kinematic, although I would do conservation of energy. So put the 0 point down here now. Make this the 0 point at the bottom. So what type of energy do they start with? Kinetic plus potential of gravity. And then that's going to end up as kinetic at the bottom of the hill. So we go 1/2 mv initial squared plus mgh equals 1/2 mv final squared. The only thing we don't have is v final. So when you do the algebra, v initial squared plus 2gh, and then we plug into that. So v initial is 6.824. 6.824 plus 2 times 9.8. The vertical drop is 10 meters. So you find out their velocity at the bottom of the hill is 15.6. And that should be the answer, I hope. Is that the answer? That's a sequence problem. First find this, then find this, then find this, then find this,